Hello everyone and welcome to this new short tutorial breakdown where we are going to be talking about this shot, about waterfalls and rivers. I have to say that this full project is available on my Gumroad page. The link is in the description, so if you want to purchase it, it's in there. Because we are not going to be talking about the shading, the lighting and the rendering of this project, and we are going to focus mainly on the effects. Alright, so we are going to talk just a little bit about the layout. I always like to start my shots by creating a basic layout just to have some shapes or some kind of proxies that match the cameras and that I think that the shot is going to work well with those shapes, those size, and then I will move to the actual high resolution environment because I don't want to start placing high resolution rocks and grounds and wherever and then figuring out that I don't know where to place them or they don't fit the camera and everything is more heavy. So yeah, I think it's always a good idea to just scatter in some boxes and have a general idea of where everything is going to be placed. And then we start creating the high resolution environment. We are just taking a bunch of free rock models from CG Trader, I believe, and we are going to start scattering all these high resolution rocks based on the layout that we previously did, because we know that that layout is fitting the cameras and is working nice for the shot. And we are going to create something that we can use for our flip simulations, because all those type of simulations are going to be very dependent on the type of environment that we create. So you probably want to spend some time creating an environment that you know that later when you do the simulations they are going to be creating some good shapes, some vortex, some turbulence, and something that is going to look cool. And now we move on to the effects layers. We are going to start talking about the river, which is basically made of a basic flip simulation, a whitewater simulation, and a underwater volume simulation. Talking about the colliders of the simulation, we don't really need to collide with the whole environment, so please be efficient and cut the parts of the environment that are not interacting with your simulations or that you think that is not going to interact with your simulations, because you don't want to waste processing power by just computing the whole environment for the simulation. And then for the simulation itself, we just need two things. First initial state of particles, which are going to be present in the simulation from the first frame. And also we need an emitter, which is going to be spawning particles every frame and is going to be in charge of creating that flowy river. Both things are made in the same way. We are just creating a box shape and assigning some velocities that has the same type of flow as the river, and we use the environment to cut the parts of that box or that shape that is colliding with the environment itself, so we have something that is not intersecting with the environment. Moving to the simulation itself, there is nothing fancy here. We are just bringing our initial state for the first frame and we are spawning particles using a pop source that is linked to our emitter, and we have some vortex confinement, a pop drag and a pop group to isolate those particles that are more in the waterfall part. And then in the flip solver we are just creating the boundaries of the simulation, making sure that we have a vorticity attribute and droplets turn on, an ID attribute, and we have an attribute to age the particles, and we also have our colliders in the simulation. I'm also creating a wet map, which is going to be used later on the shader to create that wet feeling on the rocks that are interacting with the flip simulation. And this is really easy to do. We just need to scatter points on the environment. I'm also filtering those points based on if I know that they are going to interact with the flip simulation, I keep the points, but if not, I delete the points. And we bring our flip simulation also, and we assign to the flip simulation a wet attribute because that's the attribute that we're going to transfer to the points. Inside the solver, as I said, we just need to take the flip simulation and the environment points that we scatter, and we are going to use a PCOpen and PCFilter function to transfer that wet attribute, and this will be similar to just do an attribute transfer. In this case I'm using Vex, but you can do in the way that you prefer. We just need to make sure that we have a good distance and a number of points that fit that transference. And of course we need to compare this value to the value of our previous frame, because we need to take the max value between those two values in order to keep this wet map consistent. And we are also need to decrease the value by time on the previous frame to have that fading feeling on the wet map. And just by doing this we can have a nice wet map that we are going to use later on the shader. For creating the surface of the fluid, I'm not a huge fan of using the particle fluid surface node to create that mesh. I just use it for visualization purpose. So I'm going to use BDB nodes, which are the BDB from particle node, the BDB smooth to create a little bit of a smooth on that surface, and then just convert everything to a mesh with a little bit of activity to avoid having a lot of polygons. And then we jump to the whitewater emitter and the whitewater simulation. In this case, this whitewater emitter is going to be made of two different masks. The first one is taking the flip surface, and I'm just calculating the curvature because that's usually where the whitewater will be created and the particles will be spawned. So yeah, we just calculate the curvature of the mesh and we scatter points on that curvature attribute, and we are also deleting the points that are isolated because we don't want to spawn particles on those points, and we keep the clamps, I will say, and this will be the first mask. The second mask is based on the flip points, and we are using our vorticity attribute, but we are not really interested on using all this mask by itself. We are just interested on the vorticity points that are close to the environment rocks, so we filter those points by distance and we combine it with the other mask, and we have our emitter for the whitewater. Jumping on to the whitewater sim, we need our emitters, and we also need our surface and velocity field from the flip simulation, and we are using a custom pop simulation. To create that whitewater, we just need to create the particles using our emitter, using a pop source, and then we make sure that every point that is inside of that surface field is going to be pushed to the surface, and of course we need to update the velocities of those points because we want the points to flow with the same velocity field that our flip simulation has. So if the point is inside the surface field, we are going to use the velocity field from the surface, but if the point is outside that field, it's going to use the velocity from the emitter itself. And finally, we are also trying to create a little bit of clamping on the particles using a PCOpen and a PCFilter function to create that average position between the nearest particles, and we are using the H attribute to drive that interpolation between the position of a particle and that average position between the nearest particles, so we create that clamping feeling. I'm also creating another underwater volume layer using that same whitewater simulation just to have some kind of complexity underwater. And now we move to the waterfall itself. And the first thing that we need to do is to create the waterfall emitter. And for doing that, I'm creating a curve, polyextrude the curve, and creating a BDB from that. And taking the points from the flip simulation and deleting everything that is inside of that polygon that we just created from the curve. And as you can see, we delete all the points that we don't want, and I'm doing this 2 times with 2 different curves with the same shape, but I'm just transforming the curves, and I'm isolating only the points that I am interested in using for our emitter. And inside the waterfall simulation, we just need to bring our emitter. In this case, I'm using a pop source, and we are giving some life attributes and some velocity attributes to those points. And we also need to create a custom density field, which is going to be transformed into a density attribute that basically tells us how many particles are in a voxel. So particles that are more isolated will have a lower density attribute, and areas with a lot of particles will have a higher density attribute. And why we would like to do that is basically because we want to modify our velocity attribute based on that density attribute. So areas of low density will have a bit of turbulent noise, and we will also decrease a bit the velocity every frame. So we will create that areas of straight clamps that are not affected by the air because they are really dense, and areas of isolated particles that will be reducing their speed constantly because the air is affecting them a little bit more. And finally, to create some secondaries on the waterfall, we are doing different type of pyro simulations, but basically we are taking the points of the waterfall simulation and we are creating a density attribute based on the age of those particles. So more or less you will think on this age attribute as something that goes from top to bottom, from 0 to 1, and then we are going to use that density attribute to rasterize the particles and do a very basic pyro simulation that is going to fill the gaps between all those particles that we have on our waterfall simulation. And we are just doing 2 different pyro simulations. It's the same setup but with different settings, so this is the result of that 2 pyro simulations together. And to create that feeling of the waterfall is colliding with something, because there should be something on the bottom part of the waterfall. Maybe it's a rock, maybe it's water or something. We are also including 2 more pyro simulations. Both are the same with different settings. We are just merging those 2 pyro simulations to create that cluster feeling. And we are just taking the particles from the waterfall simulation. We take the bottom part of them and we run a particle simulations of those particles colliding with a ground that we just put in there because we needed to have something to collide with. And then we are just taking those points that are colliding, rasterizing those points using again a density attribute, and we run a pyro simulation that is going to create that feeling of particles, the waterfall itself colliding with something in the bottom. And as I said, these are 2 different simulations. We are using different settings, but the setup is the same, and we are just merging them together. As I said, all the files for this project are available on my Gumroad page. The link is in the description of this video, so if you are interested in learn how I built all the layers step by step, how I did the shading of the effects, the lighting, and the rendering part of it, you can purchase the file, because I'm not a huge fan of creating really long videos, so I just wanted to give you the basic ideas of how you will do rivers and waterfall in Houdini. But I think the best way to learn is just to try and take these ideas and just come up with something by yourself and experiment and see what you can do and improve this setup and these techniques.